All right, let's go over some specific heat and calorimetry calculations. So number one says, what is the specific heat capacity, C, that a substance has with mass 25 grams, M, and 525 calories, to raise its temperature by 15 degrees Celsius. So we're given temperature as 15 degrees Celsius. And note that this is in calories and it gives you a conversion factor. So you're going to have to um, convert calories. So 525 calories, one. And then it says 1 calorie is equal to 4.184 joules. And so your joules is going to be 2196.6. So this is the value that you're going to be working with. You always got to convert if it's not in joules. So we have Q here equals M cat MC delta T. And then we're going to get our variables all ordered out. So we have Q that's given. This is calories, which is in Q variables. So we have Q equals, 2196.6 equals mass, 25 grams. C, we don't know, times the temperature. Since it's raising the temperature from a certain temperature upwards by 15 degrees Celsius, we're going to just put 15 here. And then we're going to solve for C, which is the specific heat capacity. And so using this equation that we set up, it's going to be 2196.6 equals 375 times C. And so when we divide by 375 on both sides, we're going to get a value of C, which is going to turn out to 5.8576. And so we're just going to round this all up to a nice, we'll say 5.9. 5.9. We get 5.9. And then the units for specific heat capacity is going to be, for our purposes, joules per gram times degrees Celsius. And so your answer is 5.9 joules per gram times degrees Celsius. All right, let's try number two. A 25 or 75 gram sample of Ag metal is heated to 30 or 80 degrees Celsius and dropped into 50 grams of water at 23.2 degrees Celsius. The final temperature, let me mark all these first. Final temperature of the Ag water mixture is 27.6 degrees Celsius. What is the specific heat of silver? So we want to find the C for silver is what we want to know. That's what we want to know. And since we're given the specific heat of water, the specific heat capacity of water as 4.18 joules per gram times degrees Celsius, we can put our equation Q equals MC delta T into use. So we're going to put Q equals MC delta T. And then since we know the mass of water right here given 50 grams times C, which is 4.18 times delta T. So delta T you want to be real careful with, because the delta T, here, let's do it on this side, delta T of water, H2O, is going to be temperature final minus temperature initial. And so temperature final of water is going to be 27, because it says temperature silver water mixture is 27.6 minus the initial, because it was dropped into water, initial temperature at 23.2. This will give you a heat value of 4.4 degrees Celsius as the temperature. So you're going to plug 4.4 into here and you're going to solve. And so your answer should come out to be around 919.6 joules. All right, so that's part one. So we know the heat because of the law of conservation of mass, the amount of joules in energy in equals energy out. But if you're entering 919.6 joules, right? If it's positive, then what goes in is positive. Then in order to cancel it out, then if positive goes in, then a negative energy must come out. So we know that the heat required for silver metal is going to be Ag is going to be negative 919.6. And so now we can just use this in the same equation, Q equals mc delta T, and we're going to put 919 equals M for silver metal, which is 75, and then C, which we don't know. We're looking for C, and then we're going to put temperature. So the temperature, delta T, temperature, change in temperature, for Ag is going to be the same Tf, temperature final, minus Ti, temperature initial. And so we got to be real careful with this one as well, because temperature final of the silver is going to be 27.6. 27.6 because you're putting as you put the metal in the water and the water mixture was 27.6, and the initial is going to be 80 degrees Celsius. So 80 degrees Celsius. And if you calculate it, you'll note that your answer comes out as negative 52.4 degrees Celsius. And so this is important because it'll cancel on later on. So your temperature is negative 52.4, and then you're going to calculate that. And the same way you calculate this for C in question number 1, you're going to multiply everything together and cancel it. So you're going to have negative 919.6 divided by negative 52.4 times 75. Write that clear, 4 times 75. And this will give you a positive number. And so the C value for silver metal is going to be about 0.22, and the units are the same, joules per gram times degrees Celsius. That is going to be your answer. And it's important to note that you have to remember that a negative fraction over a negative fraction will give you a positive whole number in the end, because you're dividing a negative number by a negative number. All right, let's try question number 3, and let me clear all of this out. All right, so it says, how much heat is required to raise the temperature of 400 grams of silver to 45 degrees Celsius? The specific heat of silver is 0.24 joules per gram times degrees Celsius. And so you have to evaluate what variables you're going to get. So we're looking for how much heat. So we don't know what Q is. Q is question mark. Raise the temperature of 400 grams silver, Ag, mass, and to 45 degrees Celsius. So this is going to be T. And it gives you the C value, C equals, or C equals 0.24 joules per gram times degrees Celsius. And so this is going to be your C value. So all you got to do for this one is very simple. You got to plug it into your equation. Q equals mc delta T, mass 400, C, which is 0.24, and T, which is 45. 45. All right, and then when you multiply all that together to find your Q value, you're going to end up with 4,320 joules. 4,320 joules. Okay, now let's take a look at number 4. How many joules of heat energy, so it's asking you for Q already off the bat, you can know, required to raise the temperature of 100 grams of aluminum mass from 52 degrees temperature to 172 degrees. Now we get to see the temperature delta T. So it's this 52 degrees is temperature initial, and this 172 is temperature final because it ends up as 172 from 52 degrees Celsius. You got to note that the specific heat capacity, C, for aluminum is 0.9. So all you got to do for this one, same thing. We just got to plug it in. Q equals mc delta T. And then you're going to get Q is unknown. M, 100 times C, which is 0.9. And then change in temperature right here equals temperature final, TF, minus temperature initial, which is going to be equal to 120 degrees Celsius. So 120 and there. And then when you solve all that, you should end up with 10800 joules. And you can, if you wanted to, you can change that into scientific notation, but I'm not going to do that here. So your Q required is 10,800 joules. All right, let's take a look at the last question. Suppose 100 grams mass of water, solid, so it's going to be ice, absorbs 1255, so 1255 joules of heat. So that's your Q value. Q. What is the corresponding temperature change? The specific heat capacity, C, for solid water, which is ice, is going to be 2.1. This is pretty simple as well. You're given Q, you're given M, you're given C. You're going to find the temperature, question mark temperature, for your water. Now, all you got to do to set it up is use the same equation, Q equals mc delta T. And then you're going to plug in, this time, for Q, 1255 1255 equals mass 100 times C 2.1 times some delta T. And now all you got to do is multiply 100 times 2.1 and then proceed to divide it on 1255. Then your T value, your temperature change value that it asks for, is going to be around 5.9, which I want to round to 6 degrees Celsius. So your T value is going to be 6 degrees Celsius. All right.